Hi, this is Andrea Hendricks, and I want to talk to you about how to use a graphing calculator to graph polynomial functions. Specifically, you should be able to find the domain, the range, the maximum and minimum, x-intercepts, the intervals where the function is increasing and decreasing, the intervals where f of x is greater than 0, greater than or equal to 0, less than 0, and less than or equal to 0. All of these can be found by the graph of the function. Now, let's go back and talk about these a little bit in some detail. The domain for every polynomial function is all real, so there really should be nothing to guess at for that. The range, if it's an odd degree, the range is all reals, remember, because of the end behavior. One goes down, one goes up, or vice versa, so it covers all the values of x. It's only when the function is even that you need to use a calculator to find the range. The maximum or minimum are the turning points, if you will. And to find those, we're going to use the trace feature. So if we press second and trace and choose either maximum or minimum. The x-intercepts, we will need to use the 0 function. That's accessed by second trace. And then where it's increasing or decreasing, this is based on the turning points. So turning points is where it goes from increasing to decreasing or vice versa. Greater than or equal to 0 is where the graph is above the x-axis. And you're going to need to know the zeros to determine this. And less than 0, less than or equal to 0 is where the graph is below the x-axis. And again, the zeros will help you know those intervals. Now, in the textbook, you're going to be asked to find a comprehensive graph. Remember, that really just pictures all the intercepts, the y-intercept, all those high and low points of the graph. Determine the maximum or minimum points. Tell if they're an absolute min or an absolute max. Remember, absolute min or absolute max will only occur with an even degree function. Determine the range and determine all the intercepts. In these particular problems that you were given in the book, one of the x-intercepts is an integer, it says, but those are not. You're going to approximate to the nearest hundredth. Determine the y-intercept analytically. That just means plug in 0 for x. And then give the intervals where the function is increasing and decreasing. So let's take a look at how we can go through and do this. I have an example that I've selected from those that list of problems that I just showed you. P of x is equal to negative 3x cubed plus 6x squared plus 39x minus 60. So what I would suggest when you go to your calculator and input the function into y1, remember that you need to use the caret symbol for exponents that are greater than 2. We enter this and then go to start at least in the standard window. So zoom and 6. And this is why I want you to do that. Notice that the degree is 3, so we can have at most 3 zeros, which we do in this case. Now, we could also have at most 2 turning points. The other thing that I want you to notice is the end behavior. The end behavior of this graph is, since it's a negative degree odd function, the end behavior is going to look like this, right? So, looking at this picture here, we know that, in fact, let me take a picture of it for just a minute and paste it in here so I can talk to you about it. Here is our end behavior, right? It's up, it's coming down, and then it's coming down here. So what happens somewhere in between, there's a minimum point and there's a maximum point. So we need to find out what those extreme points are. We also need to find out what these zeros are. Okay, so on the calculator we have some work to do. So let's start by doing second trace, and we'll start with the 0 function. So now you have to be real careful here. The left bound is 0, negative 60. So it's starting somewhere down here, okay? 0, negative 60 is on our y-axis. And in fact, I forgot to do that. To find the y-intercept, we just plug in 0, right? Let me go ahead and do that. By doing that analytically, I would plug in 0 for the x. Everything goes to 0 except for this negative 60. So the y-intercept is 0, negative 60. And when you press the first key to trace on, if you haven't been anywhere else on the graph, it's going to start at that 0, negative 60. Okay, so let's kind of bring this up to where we can see it. Okay, here we go. So my left bound will do this 0 right here. Left bound, enter. Right bound, enter. And then guess. Okay, so 1, 0, it said to approximate to the nearest hundredth, I think, is 1.45. Okay, so let's put that on our graph here. That's at 1.45. We need to find this other 0, so we press second, trace, 0, and go over to the right here. Okay, you can see in the window, I already went down to negative 16. Okay, it's at 8, it's right there, so we can press enter. And then enter, and enter for the guess. So it's at 4, 0. And then we need to find one more. Press second, trace, 0. Now, the left bound, we need to come over here. So remember, we're in the standard window, so let's see, that's -1, -2, -3, -4. So let's enter a -4 for our x. Okay. And that's in the positive value, so we press enter. And then a right bound will go to the other side of that, maybe -3. Yes, and so we see that we're surrounding this point, and then enter for the guess. So it's -3.45. That beats having to scroll back and forth everywhere. Okay, so we have our zeros. The other thing that we need to do is find an appropriate window to view everything. So notice that the zeros are all occurring between -3.5. I'm sorry, I read that wrong. -3.45. Oops. And 4. So if I wanted to find out where those turning points are, that is the key points, circumference of graph, I'm going to look at my table, do second and graph, and let's see what's happening to the values between -3.45 and 4. So do you see that at -3 and -4, there's a 72 there and a 270? Okay, in fact, we know that to the left of -3.45 is going off to infinity, so I would expect those values to get larger and larger and larger, so I don't really have to worry about that. What I need to look at is what's happening here, how low does it go and how high does it go in between those other intercepts. So between -3.45 and 0.45, notice that I see a value of like -90. Okay, so maybe we'll choose like -100 to see if that will work. I'm just going to put that down there just to help me remember. Then we also need to see what's happening between the 1.45 and the 4. Okay, and see it's going up to 18, 30, so maybe we choose 50 for that value. Okay, so let's see what we can do here. At our window, -10 to 10 is fine because all the intercepts are shown in that window, so I don't need to adjust those at all. Let's try our y min to be -100. Oops. And our y max to be 50. And maybe our scale is 10. Okay, that gives me a comprehensive graph, so I've done well there. So what I need to do now is determine what these turning points are. So if we press second and trace, we can do minimum. Now minimum is this point down here, so I'd have to go to the left side of that and press enter, and then go to the right side of it and press enter, and then go to that point. So it is at negative 1.52 and negative 94.88. Okay. Now we need to repeat this process, except this time do our maximum point. So we need to get on the left side of that point and then on the right side of it. And then guess. So this is at 2.85, 30.44. Okay, so let's see if we can get a feel for everything that we need to know now. We were asked to find out what are the absolute max or min. Well, there are no absolute max or min because it's an odd degree function, right? What about the local min? The local min is negative 1.52, negative 94.88. The local max is 2.85, 30.44. What else do we need? The domain is all reals, right, because it extends indefinitely from the left to the right. What about the range? Right, it's all reals as well because that goes on forever and ever down and forever and ever up. So remember, an odd degree function has a range of all reals. Now, what about where it is increasing and decreasing? Where's it increasing? It's increasing where the graph is rising, so from there to there. So we need to know what are the values of x for that piece. And it is from negative 1.52 to 2.85. Now where's the graph decreasing? It's decreasing from here to here, right? And also from here on forever. So that's from negative infinity to negative 1.52. And then to the right of 2.85, which is 2.85 to infinity. Now if we had to add some components on that this problem in the book didn't ask us, let's think about where is it greater than or equal to 0, less than or equal to 0, and so on. And also state the zeros. Let's go back and do that for a minute. The zeros of the function are what? X is approximately equal to negative 3.45, 1.45, and 4. Now, where is f of x? Let me choose a different color here. Where is f of x greater than 0? Okay, now my graph is going to get really messy here. Greater than 0 is where it's above the x-axis, right here, and also here. So greater than 0 is dependent upon those intercepts, right, not the max or min. So it would be from negative infinity to negative 3.45. Now remember I use parentheses here because I'm not allowed to include that endpoint because it's strictly greater than 0. And then union 1.45 to 4. Now where is it less than 0? Less than 0 is where it is below the axis, right? So that would be from negative 3.45 to 1.45, union 4 to infinity. And then if I had greater than or equal to here, I would just use the brackets around those endpoints. Okay. Now let's do one more graph. So let's enter this. We have what? Negative 3x to the 6th plus 2x to the 5th plus 9x to the 4th minus 8x to the 3rd plus 11x squared. And what's the rest of the problem? Plus 4. Okay, let's start in the standard window. So let's do zoom in 6 to see what we find. Okay, now what's true about our end behavior? Our end behavior is it's an negative leading coefficient on an even degree function, so it should both be down, right? And that's exactly what we see at the end. So we know the endpoints. We know how many turning points, or rather intercepts it has. It has 2 intercepts only. That's because we already see the end behavior here. So we need to find out what's going on in between there to set a good graph, or a good window to view that. So let's see what, it looks like between -2 and 2, but we can confirm all of that. So let's do our second end graph to find out the table values. Okay, between -2 and 2, it looks like it goes up to 27. So maybe for our window, we set our y max to be 30, and maybe our y scale is 5. Oops, if I type in the 30 and graph. Okay, I'm missing some values over here. So let's go back to second and graph. So between -1 and -2, it must get larger than that. So let's go back to our window and maybe we'll put in 50 and graph. Okay, that's right at the value. I think we can refine that a little bit. In fact, let me narrow our window to be -5 to 5 and -10 to, let's do 75 just to be on the safe side, and maybe we'll make a scale of 10 and now graph it. Yeah, okay, so we have everything that we need to see there. So what are those intercepts? Well, you can actually see that from the table. Notice at -2 and 2 we have a y value of 0. So we know that our zeros are -2 and 2. Okay. And we need to figure out those turning points. So if we do second and trace, they're both maximum, so we would choose number 4. And notice our left bound is at 0, 4, so let's do this one to the right first. So we'll do the left of that point, and then go to the right of it. Oops. And then guess. So what is that? 1.59, 29.02. What was that? 29.02. And then our other max, do second trace, max. We need to be on the left of this, so let's choose like a -3. And then the right of it would be like -1. And guess. So that's -1.57, 52.75. Okay, so we know everything we need to know from the comprehensive graph now to answer the questions that we need. We know the domain of this function is all reals. The range of the function from bottom up, the highest point is 52.75. Now remember, that's an approximation. I'm going to put the bracket there, but we're really approximating that point. What else do we need to know? Our local max, there's 2 of them, at -1.57, 52.75, and 1.59, 29.02. And the first one that I listed is also the absolute max. The zeros of the function are -2 and 2. So where is the function increasing and decreasing? Oh, you know what? I missed one, didn't I? Just seeing that. This point here is a local min. Our local min happens to be our y-intercept point, but we can confirm that. Sorry about that. We do second trace min to be on the left of that, so I'll put in like -1. And to be on the right of it, we'll put in 1. And guess. Okay. -1.68 e to the -6. That means times 10 to the -6. If you remember, that means move the decimal point 6 places to the left, which is basically 0. So this is the point 0.04. Okay, and that actually is our y-intercept. If we plug in 0 for x, right, 0 to the 6, 0, 0, 0, 0, we're just left with 4. So I need to correct this up here. Our local min is 0.4. So where is it increasing? Well, it's increasing as we go up here and here. So that would be from -infinity to -1.57. Well, I'm sorry, I can put a bracket there because that point is included. Union 0 to 1.59. Where is it decreasing? That's where the graph is going down, and that is from -1.57 to 0, union 1.59 to infinity. Okay. Now, where would the graph be? Let's say where f of x is greater than 0, and f of x is greater than 0, where the graph is above the x-axis. And notice that it is above the x-axis between the -2 and 2. Where would f of x be greater than or equal to 0? That is there including the brackets at -2 and 2. Where is f of x less than 0? Well, less than 0 is where the graph is below the axis, and that is to the left and right of -2 and 2. So that would be from -infinity to -2, union 2 to infinity. In our last case, where is f of x less than or equal to 0? We can include the brackets on those endpoints to find that. Okay, so the calculator can help you a lot. Being able to determine the comprehensive graph, you need to really think about what the end behavior of the graph is, and then determine what happens between those intercepts or between the zeros. That is, look at your table and find out what are the large and small values of y to determine how you need to set those maximum and minimum points. Okay, so if you have any questions, don't hesitate to contact me. Thanks.